Okay, so is everybody okay with factoring number one the way I did and setting up that inequality? Okay. Are we okay with 0 and 1, or what would be on our number line? Yes? You're not nodding. Are we okay? Okay, thank you. So those just come from your factors being 0. To test a region, I can't use 0 to test this time because it's actually one of the critical numbers on my number line. I'm going to use 2 because that seems easy enough. So if I plug a 2 in, so I'm checking the right side of my number line, what I'm doing is plugging it into each of these factors. So 2 squared, 4, but then negative, right? So I know that's a negative. What about 2 minus 1? Okay, so overall, what is that region? Negative. Okay, did the 1 have any multiplicity on its factor? No, right? It's not x minus 1 squared. So on the 1, either side of it is going to alternate. So if it's negative on the right side, what's it going to be next to it? Positive. Okay, did the 0 have multiplicity? Yes, guys, remember from graphing polynomials, that's where it bounces off the x-axis. So if it's positive on one side, what's it going to be on the other side? Positive, because it bounces. Remember, think about x-axis, like it bounces and comes back up. It's positive on both sides. Okay, so the way we could write our answer is negative infinity to 1 with a bracket, because it's this entire positive part, including those values. So you need to get used to using the number line because it's going to come up in other things that we do. And you didn't just not do the number line, you just had a bunch of stuff that didn't match the problem and then had an answer. So if that was on an assessment, I'd be like, no, like this doesn't make sense. So
if you solve and you get the same thing, does that make a difference in some cases?
What do you mean if you solved it?
Like if you did negative x squared, x minus 1 is greater than or equal to 0, and you just divide it through by negative x squared, and then you add 1. So you get x is less than...
No. You get that, no. Don't divide by x's and eliminate x's. You're going to lose critical numbers. This one, because it happened to bounce, like, you just kind of got lucky on that, but that won't work all the time.
So if...
Go ahead, then you're next.
What I did was, I took just x squared out, and I took it out of the square root.
Okay.
So 1 minus x to the square root.
That works because it's an even thing that you're taking out, like an even root that you're taking out, yes. You still have to be able to do the number line for ones like number 2 and 4. Okay, so let's make sure we see it on that. But this is the answer for this one, okay? All right, number 2, you've got 2 things you have to think about. You have the numerator, so the x squared minus 4 has to be greater than or equal to 0. And also 2x plus 9 cannot equal 0. Okay, you've got both of those pieces you have to figure out. And you have to put them together. So the 2x plus 9 one, that's easy, right? X cannot equal negative 9 halves. We're okay with that? Okay. The left side here, you would want to factor this. Okay. Number line, negative 2, 2. What's an easy value to check? 0. Where does 0 live on this number line? In the middle. Okay, so 0 plus 2 would be a positive. 0 minus 2 would be a negative. So overall, what is that little section? Negative, okay. There's no multiplicity in this one, right? We don't have any quantity squared or cubed, anything like that. Okay, so my number line will alternate. It will go positive over here, positive over here. Try to move. Okay, so you now have to put these two pieces together. I'm just going to draw one big number line just so you can see all of it. So -2 and 2. We know we wanted this part over on the right and this part over on the left. But x cannot equal -9/2. Is that somewhere in the part I just shaded? Yeah, it's over here, right? Isn't this where -9/2 would be? So that has to be an open circle. So your answer on this one is -∞ to -9/2, parenthesis, parenthesis, -9/2 to -2 bracket, bracket to infinity. Yeah.
How do you know which way the arrows are like -2 to like -infinity? How do you know it's like going that way?
So when I did, that's what this little number line, these pluses and minuses are telling me. So are you okay with why I have a plus, a minus, and a plus?
Yeah.
Okay. I want when it's greater than or equal to 0. So that's the positive parts, not the negative part. Okay. If we were just solving an inequality and it said like less than 0, then you pick the middle part. Okay. All right. How are we doing on that one? Yeah.
Miss Cortavano had like a thing of how it was greater or. So if it's greater than, then it has the two parts.
Mm-hmm.
And then less than and. So if it's less than, it's one.
For the most part, if there's multiplicity and other things happening, then sometimes, you know, and if you have, like today we're going to solve nonlinear inequalities, you might have 5 factors. So then where's your or, right? So that's a good start, but it doesn't necessarily cover everything. Okay, let's look at 3. I don't know if you guys remember, but you had a question similar to this on your Skill 1 assessment. So the numerator, do I care about the numerator at all in this problem? No. I care about the denominator in 2 different ways. The first way is just the square root. I know that that x minus 2 needs to be greater than, and it still can be equal to 0. Because it alone would not make your denominator 0. So I have to solve that. And then I also need to look at the whole denominator here. X minus 2 plus 4 cannot equal 0. Okay. So I know x has to be greater than or equal to 2 from the left side. The right side, you can go through algebraically and solve that. But is there any way I'm going to take the square root of some number, add 4 to it, and get 0? No. So there's nothing to worry about on this side. There's no way that that can actually equal 0. So your answer to the domain on this one is just from 2 to infinity. Now, if I had written that as square root of x minus 2 minus 4, then you'd have things you'd have to worry about. You'd have to figure out what x cannot equal. Yeah, let's do minus, just to show you. So you'd add your 4. And then how do I get rid of a square root? Yep, square both sides. So I have x minus 2 cannot equal 16. So x cannot equal 18. Okay, so putting those 2 pieces together, it's everything greater than 2 except 18. So you'd want to say bracket 2 to 18, parentheses, union 18 to infinity. Does that make sense? Okay. Questions on that one? Okay. All right, last one. Multiple pieces here again. So the numerator we care about, x plus 5 has to be greater than or equal to 0. So that's one piece. Denominator, x squared minus x minus 6. Do you guys see how this time that just needs to be greater than 0? Right? I don't want it to be equal to 0 because then I'd be dividing by 0. No good? Okay. So this left piece, x has to be greater than or equal to -5. Right side, practice your number line. So I've got -2 and 3 on my number line. What's easy to test? 0, 0's in the middle. I get a negative times a positive, which is negative. Will my number line alternate? Yes. Okay, so I want not the -2, not the 3, but these ends. But then is there something I have to skip over? Yeah, what is it? Yeah, and let me even just write one big number line because you've got -5, -2, 3. This is just to visually give you your answer. I know that, but then it also has to be greater than or equal to -5. Okay, does that help you see where they overlap? Okay. Whoa, that doesn't help you see. So your answer here would have been hard bracket -5 to -2 parenthesis, union parenthesis, 3 to infinity. Yeah, okay, good work. Okay. So if x actually equals -2 or 3, that would make your denominator 0. I don't want those. So that's why we did greater than instead of greater than or equal to. Okay.
I'm still confused on question 3.
Okay.
How would you know by looking at it that it does equal 0?
So the denominator can never equal 0. That's all. Anytime you have a fraction, you have to check for that.
You said that it was.
Oh, like the way I initially wrote it?
Yeah.
Okay, because you had a square root. A square root's going to give you a positive number, right?
Yeah.
Right, because we don't, otherwise there's no negative in front. Yeah. And then it was +4. So a positive number +4 is just never going to be 0. Yeah, of course. Okay. Oh, go ahead. Yeah.
I already know that I can't be like an imaginary, like y side, so like, is it like
So when we're doing domain, we're looking at the real number system. And so that's why we have to give values that will give real answers. So like the square root of x minus 2. X has to be greater than or equal to 2. Otherwise, we would get an imaginary solution. Like your graph of a square root. So let's say if I graphed that, it would look like that. Do you see how your domain is 2 to infinity?
Yeah.
Because those are the only real numbers. Okay, does that help a little?
Yeah.
Okay. I'm thinking next time on review day, we need another warm-up on domain, perhaps? Yes? Okay. All right. Yeah.
So for it was -2 going to -infinity, and like it kind of stopped it at -5. I just wondering why.
So I didn't. Like if I'm just looking at the one piece, this -2 to infinity, it's going this way forever. And then -5, that one starts at -5 and goes this way. My answer is where I get both blue and green. Because it has to be true in both. Because if I picked something past -5, like -10 over here, that'd be fine in the denominator. That give me real numbers, but -10 up here wouldn't work. So the answer is like both of those combined.
It's both of them because they both have values, right?
Yeah, so anytime you're looking at domain, your square root gives you restrictions on the domain.
But like for this one has to be true for both. That's the double restriction.
Yeah.
Wait, so for with this whole thing, we're looking at real roots, not imaginary.
Right, because domain imaginaries are not included in your domain.
Okay.
Yeah, we're looking at real numbers. Okay, after that doozy of a warm-up, are you guys ready for some notes?
Takes 36.
The warm-up took us a third of the class. That's okay.
It'll be a long day.
Oh no.
What's recording?
Yeah.
And like 20 minutes in, it's going to be actual. There's only 2.3 minutes.
All right, we're doing some nonlinear inequalities, which, guys, that's really what we were just doing. Very similar process. And we are doing what is called partial fraction decomposition. Good times, right? It sounds scary. It's definitely something that you've never done before, so.
Oh, nice.
Hey, sometimes that's better because I don't go, don't you remember this? Like, I can't ask you that. You shouldn't know it yet.
And everyone gives you a blank stare back.
Yes, like when I asked for domain this morning. Yes. All right, so we're going to start by solving some nonlinear inequalities. X minus 3 quantity squared times x plus 2 times x plus 4 cubed is greater than or equal to 0. So, remember those number lines we were just doing in our warm-up? We're going to solve this with a number line. Now, technically, you could also graph this polynomial function and tell me where it's above the x-axis, like that's what this is asking you, but we're going to do it on a number line first. So what are the critical numbers on my number line?
3, -2, -2.
Good. And make sure they go in order. So guys, this is not a domain question, right? This is a polynomial. The domain's all real numbers. There's no fractions, no square roots. We're simply using the number line because it's an inequality that we're being asked to solve, okay? Just want to make sure we're clear on that. All right, what's easy to plug in and check? 0. 0 is going to live between the -2 and 3. So if I plug 0 into that first factor, the x minus 3, you get -3, but then it's squared. So is that positive or negative?
Positive.
Okay. What about 0 plus 2? Okay, 0 plus 4. Okay, so this little region is positive. Now, you can absolutely plug in a number for every single section. I think that takes too long. If you understand multiplicity, you can easily figure out the rest of the regions. So I'm going to look at the 3. Does the 3 have multiplicity?
Yes.
Yes, even multiplicity, right? Graphically, it's going to bounce off the x-axis. So if it's positive on the left side of 3, what will it be on the right side of 3? Yes, okay. All right, then I'm going to look at the -2. Does it have any multiplicity? No, so if it's positive on one side of it, what will it be on the other side? Okay. All right, now the -4, it has multiplicity, right? But it's odd multiplicity. What does odd multiplicity do for you graphically? Inflection. But doesn't it still go from like negative to positive or positive to negative?
Yes.
Yeah, so what do you think it's going to be on the other side of -4? Okay. So really, even multiplicity is the only one that's going to impact that alternating number line. All right. This question said, when is this greater than or equal to 0? So that's this end over here. I'm going to include the -4, include the -2, include the 3, all of that. So how do I write the answer?
Infinity to 4 included,
Okay.
and then it's from -2.
Yes. You don't have to separate it out and say like -2 to 3 included, 3 to infinity. Yeah, 3 is included. Just keep going. Okay. If it's not included, then yes, you'd have to jump over it.
Why did you put the what does the green stuff mean?
That's answering the question of where is it greater than or equal to 0.
Oh, the positives are all greater than. Okay.
Yeah, so I'm just like shading the part of the number line to make sure I write the right answer. Okay. So graphically, I can just show you what this looks like too. If you were to graph a polynomial like this, you'd have a 0 at -4, -2. Even degree, so both ends are up. I know it bounces here. Across here. You get an inflection point here. So do you guys see if I'm asking you when it's above this x-axis or on the x-axis, how that matches up with -infinity to -4 and then -2 to infinity? So it's the same idea. So if you really like graphing polynomials, go for it. Be aware of the number line though. Okay, we can do these with rational functions too. So let's do x plus 2 cubed times x minus 4 over x minus 1 quantity squared times x plus 5 squared. And this is less than or equal to 0. Technically, you could graph this rational function. I do not want to graph that rational function with all that multiplicity going on. No, thank you. The number line test will definitely be easier. So guys, try it for me. It's the exact same thing. You're just plugging into the factors. See if you can figure out where this is less than or equal to 0.
Do we have to worry about the domain restrictions for the 0?
Good question. Check in with each other once you have something to check in about. So right or wrong, you're in it together, right? still working. I'll give you another minute here. Talk to your neighbor. How are you doing? Gonna make it, Erin? Are we overthinking it, guys? Or, yeah, a little bit? Always. Okay, let me walk you through it. What is easy to plug in? 0. They're in a fraction, but you really just have 4 factors that you're plugging it into, okay? So 0 plus 2 would be positive, cubed, still positive, right? Okay, what about 0 minus 4? Okay. 0 minus 1 is negative, but then I square it. Positive. 0 plus 5, positive. So overall, what is that little section? Negative. Is everybody okay getting to that point? Okay, now it's figuring out your multiplicity, where it's going to be positive, negative, all of that. I'm going to start with the 1 next. Does the 1 have even multiplicity?
Yes.
Yes. So what is it going to be on the other side of 1? Negative. Does the 4 have any multiplicity? No. So what will it be next to it?
Positive.
Okay. Now I got to work the other way. The negative 2, it has multiplicity, but it's not even, right? So what's it going to be on the other side?
Positive.
Okay. The negative 5 has even multiplicity, so positive. Are we, look at your number line, guys. Are we okay with the pluses and minuses? Good.
How did you know what to do the plugging in the numbers for?
Like, how did I pick 0?
Yeah.
Because 0 is easy. If 0 is not one of those numbers on there, I always use 0. Like if it's not one of the critical numbers on my number line, I use 0. Pick 1, pick 2. Like just pick something that's not one of your critical numbers that's pretty easy to plug in.
Okay, and then you just do the multiplicities that line up afterwards.
Yes. Are you okay with like the little plus, minus, plus, plus? Okay, yeah. Yep, and then it's multiplicities from there. Okay, then it's asking me less than or equal to 0. Okay. I know that's the negative part, so it's just these 2 in the middle here. And less than or equal to, you'd go, oh, okay, I'm including these numbers on the number line. Am I including all of them, though? No. What can I not include? Okay. Technically, I can't include the negative 5 either, but it's way down there, so it doesn't matter. If that had been in the numerator, you'd want to make sure you include that single point. But we can include the 2 and the 4. So your answer here is bracket, negative 2, 1 parenthesis, 1 to 4, bracket. How'd we do?
And you stop at 1.
Do what? I'm sorry.
Stop at 1.
Yeah, because I go, oh, okay, right there. Like right off the bat, I know 1 and negative 5 are not going to be included in my answer. Okay. Got to keep all of that together. Questions? Yeah.
Because it's squared, right?
No, it's because an actual negative 5. Or are we talking the 1?
1.
Okay. So if I plug a 1 in here, what do I get? 0 squared. 0. 0 times this is still 0. Your whole denominator would be 0. No good. Okay? So it doesn't matter because it's not a part of the negative anyway. If this factor had, say, been in the numerator, this negative 5 would be a part of your answer. You'd have to say like negative 5 on its own and then the rest of it. Okay. Other questions?
Oh, we want it to be less.
Are we getting the number line part? Okay. One more of these, and then we'll do our partial fractions. X minus 3 over x plus 4 is greater than 3. 3. So we have a 3 over there, right? What do you think we'd like to have over there? 0. So I'm going to bring the 3 over. Now realize when you subtract over the 3, you can't just like smush it into your fraction, okay? You can put it over 1 if that helps you. Essentially, I'm now subtracting fractions. What do I have to do to subtract fractions? Yes. Do you guys see how it's x plus 4? Okay. So this 3 over 1, I'm taking numerator and denominator times x plus 4. Now be careful, because you're distributing a negative 3 to that x plus 4. I'm going to have x minus 3 minus 3x minus 12 all over x plus 4. So I have negative 2x minus 15 over x plus 4. All right, you guys try from there. Think about your critical numbers and do your number line test. What were your 2 points on your number line? Yeah, so did everybody have negative 15 halves first? Okay. Sometimes that's the hardest part for you guys, is putting your fractions in the right order on the number line. So if I test 0 this time, do you guys see how that's going to be on the right side? Okay, and that's going to give me a negative over a positive, which is negative, positive, negative. Did you guys get parenthesis, negative 15 halves to negative 4 parenthesis? Yeah? Getting it? Yes? Okay. Questions?
Put in a number greater than 0. Okay, and that would be 0. And then just use in
All right, guys. Partial fractions. All right, let me write the first one and then I'll explain what we're actually doing with our partial fraction decomposition. It sounds so much scarier than it is. All right, so we've got this fraction x minus 1 over 3x minus 5 times x minus 3. We're sort of doing the reverse of finding common denominators. So instead of starting with these two fractions, finding a common denominator and combining them into one fraction, we're now starting with the 1 and splitting it up into the two original fractions, okay? So we are going to start, just show you the first one. We're going to say is a over 3x minus 5 plus b over x minus 3. Right, those are the two denominators that we would have started with if we had two separate fractions. We don't know the numerators, so we're just calling them a and b. And that's what you're going to find, the value of a and b to make this true. Okay? You're looking very skeptical right now, guys. Okay, our first step. We're going to get rid of all of our denominators. So I'm going to multiply this entire equation by 3x minus 5 and x minus 3. Adam, you can scoot up if you want to. Like, you can even just pull a chair, like, way up close if that helps. Okay. Just listening. Okay.
You should come sit right there.
Sit at the table. I will post the video, okay, so if you need. All right, if I multiply that first fraction on the left by both of those quantities, do you guys see that all I would be left with on the left is x minus 1? Okay. All right, then my a fraction, the 3x minus 5s would cancel, but I'd have a times what? Okay, x minus 3, good. Plus, what would I have? B times what's going to be left there? Yes. Excuse me. All right. There's actually two ways to go about this. When you only have two fractions like this, you can do a system of equations and elimination and all of that. I actually think the second method is easier, and then that's the one that works even when there's three fractions or however many fractions you end up with. We just start letting x equal certain values to eliminate things so that we can solve for the variable we have left. So the first thing I'm going to do is let x equal 3.
Should you always start with like the zeros?
Yes. Yep, I picked 3 because that's going to eliminate an entire term here for me. So you're plugging the 3 in everywhere. Here, let me move it up a little for you guys. Actually, give myself a little more space. I'm going to write it all out. You could certainly plug it in your head, but just so you can see where I'm plugging it in. So I'd have 3 minus 1. Guys, will the a term even be there if I plug in a 3?
No.
No, and that's the whole point. You want the a gone so that you can solve for b, okay? We can't have all these variables because then we can't solve for them. So the b would still be there, and I'd plug in 3 times 3 minus 5. And now you are back to just a very basic equation that you're solving. So 3 minus 1 is 2 equals, what do I get over here with my b? 4b. So solve for b. Are we okay with b is 1/2? Weird, right? But not that hard. Okay. Yeah. Just strange. When you get, I was just going to say, when you get into calculus, especially BC calculus, being able to understand these different parts of the fraction and go through the decomposition, you have to be able to do it in BC Calc. So we start with some basic ones here, and then you get to more complicated ones in calculus. So today is the building blocks.
How do you know if you're solving for A or B?
Doesn't matter. You have to solve for both, so it doesn't matter which one you start with.
So,
Okay. You what? I'm
are
sorry.
we still in like the review of it or not?
Partial fractions is totally new to you guys. Yes. It's one of the first things that I'm like, okay, no one should know this yet today. New stuff. Okay. We now have to solve for A. You have two options now. You could do 5/3, right? Because that would eliminate the B term. You could also just use 0 if you wanted to, because we already know what B is. Okay, so whichever one you think is going to be easier, I'm going to use 0 because I don't really feel like plugging in a fraction right now. It feels strange, but you can just pick whatever x value you want. If you've got a favorite number and you really want to plug it in, it will still work, okay? So again, we're going back to the original. I'm going to let x equal 0. I'm going to write it all out. You don't have to do this. You can obviously do some of this in your head. So I'm going to say 0 minus 1 equals a times 0 minus 3 plus, instead of b, what do I want to write? 1/2. So I do have a fraction, but it's, you know, it's better than 5/3. Times 3 times 0 minus 5. And again, you can obviously do some of that in your head. All right, so I have -1 equals, are we okay with -3a? Okay, and then do we see -5/2? All right, algebra 1, here we go. How do I solve for a? Okay, what is -1 plus 5/2? 3/2, good job. So 3/2 equals -3a. Divide by -3, same as multiplying by -1/3. What do I get for a? Yeah, we're doing this is the same as, ran out of room. So -1/2 is a. All right, we're almost done. We have to actually write our answer now. Anybody questions getting to the A and the B value?
Isn't B only 1/2 when you let x vary though?
No.
It's not.
It's letting x equal 3 is the only way you can find B if you don't already know A. But just imagine it's like on a line and you're just picking an x value on that line. You can still solve for it. We strategically pick the 3 to eliminate the other variable. Okay?
Will they always have that positive negative relationship, or is that just coincidence?
Just happened on this one. Yeah.
So for the second one that you're solving, if you know the first one, you can just use that to plug in. You can put that in for B.
Yep.
But if you don't know it, you have to have it equal to 0.
Yeah, and well, our next one's going to have 3, like A, B, and C. So for one of them, you use a 0. Next one, you use one of the values. And then finally, the third one, you can pick a number. Okay? All right, so the way you write your actual answer, remember at the beginning, we had A over 3x minus 5 and B over x minus 3. We're going to substitute our A and B into that, but we don't write it as like a multi-level fraction. I'm not going to say -1/2 over 3x minus 5. So what it ends up being is -1 over 2 times 3x minus 5 plus 1 over 2 times x minus 3. And you don't have to multiply it out. You can just leave it. But do you guys see where I plugged it in? Like what you picked as your A and B initially is where you have to plug it in. We're going to do a couple more, don't worry. Even with our really long warm-up, we still have plenty of time to do these, okay?
What do you said is
All right, let's try again. 1 over x minus 3 times x plus 1 quantity squared. Let me walk you through the initial setup with your A's and B's here. Oh, sure. Sorry. Is that far enough? Okay. Yeah. Okay. Weird little twist with this one because we have a quantity squared in our denominator. You are going to end up with 3 fractions. So we're going to have an a over something plus a b over something plus a c over something. First one's easy, a over x minus 3. Okay, x plus 1 quantity squared. You sort of have to like build up to it. So b is going to be over just x plus 1. C is over x plus 1 squared. If it had been cubed, you'd have x plus 1. X plus 1 squared, x plus 1 cubed. I'm not going to do that to you. Like, this is the most it would ever be is squared. But just know that if you have some factor squared, you list it as a single and then squared.
Can't you just separate it so it's like a perfect square? No?
Nope. Because if you had x plus 1 in both, your common denominator would not be x plus 1 squared in the end. So, yep, you have to have 3 factors. Just kind of remind yourself, like, the degree of that denominator would be 3. I should have 3 fractions going on here. Okay. All right, do you guys want to try it? Or do you want a walkthrough? A walkthrough, okay. What's our first step? A crawl through. It's probably fair. No, you tell me. What's the first thing we do? No, but you're not multiplying when you're finding a common denominator, right? Okay, what?
What is the denominator squared? Because you said that's equal to degree. So what if the
No. So, okay, think common denominator. What if I had 1/3 plus 1/2 plus 1/4? What's the common denominator? Not 24, right? 12. You don't just multiply them all. Common denominator, this one's 2 squared, right? Your common denominator would be 3 times 2 squared. That would cover all of them. Okay, so back here, I went the wrong way. There we go. If you actually found a common denominator here, it'd be x minus 3 times x plus 1 squared. You see it? Okay. Yes. Anytime you have a factor squared in your denominator, or like to the 3rd, to the 4th, whatever, you have to like build up to it when you're doing a partial fraction decomposition. So you have to have it linear, squared, cubed to the 4th, like however many of them there are. I won't ever give you anything bigger than squared, but you do have to have it as 2 separate pieces. Okay? All right. No one ever likes that step. They're like, why? So I get it.
Wait, why?
Otherwise, the partial fraction decomposition does not work. You will miss terms if you just do the quantity squared. It won't get you there. So you have to break it up and build your way up to it. Or did you mean, why does no one like it?
No.
I think it's obvious why no one likes it. Okay, so what do I multiply by here? Bottom, yeah, the denominator on the left. x minus 3 times x plus 1 squared. We multiply the whole thing by whatever that left denominator is. Okay, so what do I have left on the left? 1. Seems simple, right? We like that. What will I be taking a times? So, what about b?
X minus 3 times x plus 1.
Yep, one of those. And c?
X minus 3.
Okay. We're good to that step. Do you want to try from here or still crawl through? Okay, we'll crawl. But what do we want to let x equal? 3, sure. Great choice. Okay, so on the left, I will just have a 1.
Wait, do we just make it equal 3 because that's the easiest?
-1 would be lovely also. Either of your zeros. You need factors to cancel out here, so either of those zeros. All right, a is going to be times 3 plus 1 quantity squared. Are b and c going to exist anymore? No, which is good. I need just one variable if I'm solving. Well, if x is 3, what's happening there? Yep, times 0, it's gone. All right, so I get 1 equals, what, 16a?
Yeah.
So 1/16. What a lovely, lovely value for a. Okay. It's going to be super fun to plug back in, right? Okay. What do we want to let x equal next? Yes. So smart. Okay. On the left, I have 1. What's the only variable that's still going to exist on the right? C. Yeah, do you guys see how the a and the b term are going to get canceled out here?
But if you were to write it out, you'd write 1/16 as a.
You could, and then times 0, so save your time. So it's going to be c times -1 minus 3. So 1 equals -4c. More fun with fractions. -1/4 is your c. Awesome. Okay. Now we've run out of things to plug in that are obvious from our equation. So what else is easy to plug in? 0. Let x equal 0. All right, so I'm going to have a 1 on the left. Okay, this is where the a and the c that we've already found, we have to also plug those in. So I'm going to have 1/16 times 0 plus 1 squared plus b. I'm running out of room, so are you guys okay with me saying times -3 times 1? Okay, and then minus 1/4 times -3. Okay. 1 equals 1/16, and then it'd be minus 3b plus 3/4. Now, 2 choices here. You can add your 1/16 and 3/4 first. You could subtract 1 over to the other side if you wanted. Whatever you want to do. I'm going to subtract my 3/4, I think. So I'm going to have 1/4 equals 1/16 minus 3b. Then you have to subtract 1/16 from 1/4. 3/16. Excellent. Equals negative 3b. So guys, what does b end up equaling? I heard it, negative 1/16. Yeah, because dividing by negative 3 is the same as times 1/3, negative 1/3, okay? All right, we found all the pieces. We just have to write our answer at the end here. So looking at, you can barely see it, what I have up above. A is 1/16, so I'm going to write 1/16 times x minus 3 minus 1/16 times x plus 1 minus 1/4 times x plus 1 quantity squared. That is your partial fraction decomposition answer. Questions? Yeah.
So in the beginning, I just want to ask how you got the x minus 3 and the x plus 1.
So that very first step, remember when I multiplied the whole fraction by this thing up on the left?
Yeah.
You're trying to eliminate all these fractions. So whatever this denominator is, I'm taking the whole equation times that. So that leaves me with just a 1 here. This one, the x minus 3 would cancel, so I just have a times x plus 1 squared.
Oh.
You see, here one of the x plus 1s would cancel, so I still have the x minus 3.
All the conversions, right?
Yeah, seeing like what's left after each term cancels.
Okay.
So this one, the x plus 1 squareds cancel, you're just left with b. Yeah? Okay. Yeah, if you don't see that, it's like, what? It's just, you're just writing things. What is happening? Sure. Yeah. Yes. One more, guys.
10 more.
We don't have time for 10 more. We'll do one more. I squeezed 3 of them onto one page, but I wrote pretty small. All right, 5x squared plus 9x plus 3. Our numerator is not just 1 this time, guys. I know. Over x times x plus 1 quantity squared. There you go. Try this one, guys. Woo, you can do it. Still an ABC. I'll make sure you do that step right, okay? What are we going to put A over? Okay, what about B? Okay, and C? Got it. Ready, go.
Did you get this? Oh, yeah, my too.
You get happier numbers on this one, guys. You shouldn't get any fractions for A, B, and C this time.
Wait, so is it only when you do the third one that you plug in the first two numbers? Like, make one yourself, or?
Yep.
Okay. Otherwise, you just plug in what X equals.
And guys, for your third round here, you can't let X equal 0, because hopefully you already did that. Right? So you got to pick something else. You see what I mean?
It's like around that number.
Yeah.
For the third round, you can do any number, right? It's not the most.
Yep. I pick one that doesn't make your brain explode, but you know. Appreciate it. Just
So, before the last one, so you don't want the last one.
well, this time, because hopefully you used 0 and -1 already. You can't use 0 again, so you have to pick something else. 1. You can use anything other than 0 and -1. Your last plugin, like let X equal. Yeah.
So the last,
Excellent.
so the last plugin always goes to the full equation.
Yeah, the last plugin is where you've got to use like everything you found, and yeah. Did you get 3, 2, and 1? Yeah. I'm gonna write them. So 3 over x plus 2 over x plus 1. Yay! Oh yeah, it's gonna be all that stuff. I know, that's nice.
No, don't make it any more complicated.
Done.
Wait, are we actually done?
What do you mean, how do I choose one for x?
I don't know.
Pick whatever you want. Pick 17. You still get b and c. I promise.
We got 3 minutes.
Okay, guys. Math space has been assigned. There is one question that is on there that shouldn't be on there, so I want to show you the answer to it so everybody can just get it right. I think it's your second question. It is this guy. The difference for this one than any of the others we did, you guys see there's an x squared within the factor?
Yeah.
I'm not going to give that to you, okay? That leads to this like ax plus b as a numerator because it's 1 degree less. You're not going to have to do this, so just freebie on your homework, okay? Yes, and that will be on your assessment either. I would not put that one on there. I think there's only 5 questions on your homework. That one's free, so you only have to do 4. Woo!
It's not a lot harder.
It's on your assessment.
No, I wouldn't do that to you.